So good morning students. So I welcome you in the lecture of signal system. In the previous lecture we have discussed about the basic of signals. So what exactly mean by signal? So normally we know that uh, sine wave, this is the signal. So this signal is having a period that is nothing but from this peak to this peak. Whatever the portion is called as period over there, and the amplitude we can say that from this top to this end. Okay, this end to this end means this peak to this peak. Positive peak to the negative peak. It's called as amplitude. So we can say that the peak to peak amplitude, and we can also know that this, if this is a voltage, if this is a voltage, then V max, I will say that this is V mean, I will say that. So this is nothing but my amplitude. So likewise, continuous time signal we have discussed. The signal which is continuous with respect to time, and the discrete, the signal is present at the discrete instant of time. Okay, here we denoted the signal by x of n, and in the continuous we are denoted the signal by x of t. Okay, so we'll move forward. So analog signal we have seen, digital signal we have seen also. So I think we have started with the sinusoidal signal. So sinusoidal signal, we know that sinusoidal signal is defined as a sine 2 phi f0 of t. Okay, so here a is nothing but my amplitude. Okay, then 2 pi is it is repeating with periodic with 2 pi, and f0 is nothing but my fundamental frequency. I will say that fundamental frequency. If I will convert this f0 by t, that is nothing but I can replace t and f are the what you can say, inverse. So I can, if I replace f0 by t0, then I can write a sine 2 pi t0 by t. Okay, so here the f0, sorry, omega 0, this 2 pi f0 is nothing but uh, I can represent this in radian, like omega is equal to omega 0 is equal to 2 pi f0 t. Also I can write 2 pi by t naught, where t naught is nothing but my fundamental frequency of sinusoidal signal. Okay, so we have seen these things. So unit step. So normally unit step signal which is available to you from instant when t is greater than 0. Means here I will say that t is 0 and here t is minus. So from t is equal to 0, greater than 0, a signal is present for all instant, for in all instant, and its amplitude is 1. Here unit represent its amplitude is 1. If I multiply with 2, so its amplitude would be 2 for t greater than 0, and at t is equal to 0, because it is represented for t greater than 0. So for t is equal to 0, its amplitude is half. Okay, its amplitude is half over here, and just greater than t is equal to 0, its amplitude is 1 over there, and for t is less than 0, its amplitude is 0. For t less than 0, the signal is completely absent, completely absent. Okay, the signal function I can say that defined as, for t is greater than 0, its amplitude is 1. For t is greater than 0, its amplitude is 1. For t is equal to 0, its amplitude is 0. And for t is less than 0, its amplitude is what? Minus 1. So I can show you like this one. For t is greater than 0, its amplitude is 1. For t is equal to 0, its amplitude is 0. Keep in mind. And for t is less than 0, its amplitude is minus 1. So this is called as what, let's say, a signal function. Signal function. So if I want to represent my signal function by using unit steps, so just I want to multiply 2 u of t. So what will happen with the 2 u of t? So its amplitude is increased by 2, means here 1, its amplitude will be 2, and minus 1 I will go for amplitude will be changed by minus 1 over there. So next, unit ramp signal. So unit ramp signal, how I will represent the unit ramp signal? It is continuously changing with respect to time. For t is greater than 0, for t is greater than 0, amplitude is 0. Suppose if I put t is equal to greater than 0, that it means I will write 0.1. So t is 0.1. For t is 0.2, its amplitude is 0.2. For t is 0.3, its amplitude. So whatever the value of t, it is value of amplitude. For t is greater than 0 and for t is less than 0, its amplitude is completely 0. That is nothing but here zero point 0.1, so amplitude is zero point 0.1, zero point 0.3, amplitude zero point 0.3, zero point 0.4, amplitude zero point 0.4, 0.5, amplitude for likewise for zero point 0.1 its amplitude 1. Likewise increasing up to infinite, it is increasing. Whatever the time instant, the ramp signal is plus 8. Okay, so unit rectangular pulsar or gate signal. Okay. Here, this signal is very important. Unit impulse function. So, unit impulse function is nothing but what? It is nothing but the derivative of unit step function, or unit step is integral of unit impulse. So, if you are taking the derivative of unit step, I will get the impulse signal. And if I am integrating the unit step signal, that is nothing but the integration of impulse function. Okay. So, I will show to you representation of this one. So this is represented by del of t. Okay, it is nothing but the del of t. So arrow represent its amplitude. It normal represent at one over here, and its area is infinite. Keep in mind, its area is infinite. Area is infinite over there. Just a minute. Area of okay. Area is infinite over there. So how do you represent the area? Because area is nothing but what, width into height. So if I am increasing, if I am reducing the width, its height going to be increasing. So at 0, the signal is only present at the 0 instant. So if the signal is present at 0 instant, it's having infinite height over it. Infinite height over it. So this is the feature of unit impulse function. So the properties of unit impulse function. So the sampling property, I will say that sampling property is nothing but what, minus infinity to infinity is g of t, whatever the signal is there, into del of t minus t0. So here is nothing but the shifted version of del of t. So what is meant by shifting and all, we'll see. Minus t naught, del of t, t of t is equal to g of t naught. So nothing but sample version. If you are multiplying g of t, that is signal with respect to the shifted version of del of t, then I will get the del of t naught, means whatever the signal shifting. This is the shifted version of del of t. So if I multiply my signal with respect to shifted version of del of t, then I will get the del of g of del of t only. Okay. The scaling property. Scaling property is nothing but the del of a into t minus t naught. Means this is nothing but a shifted version. So I will get 1 upon mod of a. So whatever the amplitude of a into del of shifted version of del of t minus t naught over there. So replication property is nothing but the g of t complex conjugate into del of t is equal to g of t. So replication, I will get the replication of g of t if I am multiplying with del of t. So unit impulse strain. So what exactly mean by unit impulse strain? Unit impulse strain is nothing but the sum of infinitely uniformly spaced impulses, and is given by, so del of t into t is nothing but summation of n from minus infinity to infinity del of t minus n t, capital T, where n is an integer one. So this is nothing but the, if I am adding, so suppose this is nothing but my del of t function over there, that is present at the 0 instant, and here t 2t, likewise minus t minus 2t minus 3t minus 4t, like this also. So if I'm adding this function, indefinite function, okay, so I will get the unit impulse train over there. So third is nothing but my unit rectangular function. So unit rectangular function is how I will represent unit rectangular function. So u of t plus t naught minus u of t minus t. So what exactly mean by minus and what is the plus function, I will tell you. So from minus a to a, the signal is having amplitude as 1. This is nothing but my unit rectangular function. So a triangular function. So triangular function from minus 1 to 0, its amplitude is completely increasing nature, and from 0 to 1, its amplitude is continuously in decreasing function. Okay. So sync function. So sync function is, you can observe like this one. Okay, at from minus 1 to 1, its amplitude is increasing. So how to define? Sine of pi t upon pi t over there. So if I am drawing the signal, if I am plotting the signal, I will get the this function. So how to plot the signal, I will demonstrate to you. Okay. Sampling is nothing but what? If I'm having, if I have my continuous signal, this is my continuous signal, and if I want a discrete signal like this one, so I will go for the sampling function. So sampling is nothing but what? If I'm having continuous time signal, if then I required a discrete time signal, then I will go for sampling. Okay. So so if I'm having the continuous time signal and I will go for the discrete, I will go for the sampling. So now we will see what I exactly mean by discrete time signal. So in case of sinusoidal signal, x of n is equal to a sine 2 pi n upon n naught plus theta. This is the discrete time signal for sinusoidal signal, and for exponential signal it is nothing but x of n is equal to a raised to n. So where n is nothing but my discrete time signal, okay, discrete time samples, where at the time axis n is there, a is nothing but my amplitude, theta here from theta is nothing but my phase shift in radian, n naught is nothing but what, n naught is a discrete period of wave, where 1 by n naught is equal to f naught, that is nothing but the omega 0 by 2 pi. Here you will observe the omega is like this one. Okay, omega is like this one. So this is nothing but my discrete function, and if you are observing this function, here you will find, here you will find a omega also. So this is nothing but my continuous function. So keep in mind there is two omega. So these two omega are different one. If I am writing omega like this one, just a minute. So if my omega is like this one, omega is like this one, so this is my different discrete, and if I'm writing like omega w, that is nothing but my continuous sine. Okay, so sine wave you can represent like this one continuously. So here from this end to this end the peak to peak period is there, so this is nothing but my period. So sampling, if the samples are quite uh, having large space, okay, and here the signal is having less space, so here sampling is more one and here sampling is less one. So more, if the samples are more, I can say closely, then we are getting the more reconstruction of signal. Okay, so here they are less, distance is more one, distance is again more, distance is quite small, and this is the smallest one. So you can observe this is complete sine wave. So information is more in this content as far as this signal is concerned. So second is unit step signal, but in discrete format. So you have to represent by n, small n. So u of n is equal to, for even n is greater than equal to 0, from 0 instant its amplitude is completely 1, and for 0 its amplitude is, for n is less than 0 its amplitude is 0. So you can represent by u of n. This function is represented by u of n. U of n is equal to u of n for from 0 to up to whatever the instant of time its amplitude is 1. So now it's, we are representing my time by small n, by small n, okay, its amplitude is 1. Okay, unit ramp signal. So how to represent ramp function? So n for n is greater than equal to 0 and 0 for n is less than 0. That is nothing but summation from minus m to n u of n minus 1. So I can say that ramp function, how to define? If I am putting the value of n is equal to 1, its amplitude is 1. If I am putting the n is equal to 0, its amplitude is 0. So like this one, whatever the value of n, its amplitude is 1 over there. Okay, so del of n. So for del of n, its amplitude is 1, for n is equal to 0. It is 0, n is equal to, is not equal to 0. That is nothing but del of n is present for 0. So I think we have to stop over here. So thank you very much for attending this lecture. Thank you.